Hi students, welcome to the chapter of polynomials. Polynomial is an algebraic expression involving one or more variables whose coefficients are of integers but its exponents are always whole numbers. They are not negative numbers. Polynomial x is represented by the term p within bracket x that represents a polynomial in variable x. The term p within bracket y represents a polynomial in variable y. P within bracket n represents a polynomial in variable n and so on. P within bracket 1, P within bracket 2, P within bracket 3 represents the number to be substituted for the variables involved in the polynomial. Polynomial having one term is called monomial. Polynomial having two terms are called binomial. Polynomial having three terms are called trinomial. All the algebraic identities have born out of polynomials only. Polynomial has a graphic representation. It has a degree. A single degree polynomial is in the form of ax plus b, and that is known as linear polynomial, and its graphical representation is always a straight line. And degree 2 polynomial is ax squared plus bx plus c, and whose algebraic expression, graphical representation, is a parabola pointing upwards or downwards. If the coefficient of x squared is positive, the parabola curve upwards. If the coefficient of x squared is negative, the parabola curves downwards. Now, in this chapter, we are concerned only with problems involving one variable, that is for your board exams. Let us. In the first slide here, we are concerned with the fundamentals. Polynomial is an algebraic expression involving one or more variables, as I said in the beginning, whose coefficients are of integers, but its exponents are always whole numbers. And a polynomial having one term is called monomial, polynomial having two terms is called binomial, polynomial having three terms is called trinomial. The variables in a polynomial have positive powers as exponents. The coefficients of variables could have integers, but its exponent powers should be whole numbers, and it will not have fractional exponents. The coefficients can be of irrational numbers too. The standard form of polynomial in variable px, meaning polynomial in variable x, it could be p within bracket m, p within bracket n, p within bracket y, p within bracket d, any variable for that matter. The highest power of the variable is called the degree of polynomial. The power of a constant polynomial is 0. Why? Because 4 multiplied by x to the power of 0 is equal to x to the power of 1 minus 1, which is equal to x by x, which is equal to 1. If 1 is multiplied by the constant remains the same. Also, the polynomial in standard form is always mentioned in the decreasing or increasing power of the exponents. So when you start from a higher exponent, x4, x3, x2, x1, when the constant term comes, it is constant into x0. The terms of polynomial as classified as monomial, binomial and trinomial are explained in the slide herein. Monomial is a single term, and in the single term means 4x plus 2x plus 3x is monomial. It's not trinomial because they could be added together. They are like terms. Similarly, polynomial equation 4x minus 1 is a linear polynomial. Graphical representation is a straight line. And to plot them in graph, you have to equate 4x minus 1 is equal to y, where if you give the value of x is equal to 1, then y is equal to 3. Like this, you can plot 2, 3 points and then connect these points. Then you will get a straight line. 2x squared minus 4x plus 7, quadratic polynomial, parabola curve upwards. be equated to y. If you give the value of x is equal to 0, then y becomes 7. So like that you plot more points and join the curve. Minus 4x squared plus 3x plus 6 quadratic polynomial where parabola curve downwards. Minus 4x squared plus 3x plus 6 is equal to y. If x is equal to 1 here, then y is equal to 5. Cubic polynomial 7x to the power of 3 plus 2x to the power of 2 plus 4x minus 6 curves touches x-axis 3 times. Let us say 7x cubed plus 2x squared plus 4x minus 6 is equal to y. If x is equal to y, then y coordinate becomes minus 6. Then, in linear polynomial, the straight line intersects x-axis at one point. In quadratic polynomial, the curve intersects x-axis at 2 points. In cubic polynomial, the curve touches x-axis or crosses x-axis 3 times. Linear polynomial is in the form of ax plus b, where a is not equal to 0, that is degree 1. Quadratic polynomial is in the form of ax squared plus bx plus c, where a is not equal to 0, it is degree 2. Cubic polynomial is in the form of ax to the power of 3 plus bx to the power of 2 plus cx to the power of 1 plus d, where a is not equal to 0, degree 3. Biquadratic polynomial is in the form of ax to the power of 4 plus bx to the power of 3 plus cx squared plus dx plus e, whose degree is 4, where a is not equal to 0. Constant polynomial is always called a zero polynomial. Why? Because x multiplied by x to the power of 0 is equal to constant multiplied by x to the power of 1 minus 1, which is equal to constant multiplied by x, which is equal to constant multiplied by 1, which is the same as constant. Therefore, the degree of constant is always 0. Now let us come to zero polynomial. The value of x for which polynomial becomes 0 is called the zero of the polynomial. In polynomial equation 3x minus 4, which is p within bracket x is equal to 3x minus 4, where x is equal to 4 by 3. If you substitute p 4 by 3 in this equation, the polynomial becomes 0. This is called the zero of the polynomial. The zero of the polynomial is given by the coefficients in the equation, and it is explained in the following table. Linear polynomial 4x minus 8, the zero of the polynomial is represented by coefficients minus b divided by a. We call the zero of the polynomial as alpha and beta because there are two zeros to any quadratic polynomial. It has two factors, then we can get two zeros for that quadratic polynomial. In quadratic polynomial x squared minus 6x plus 8, it has two zeros. So one zero is called alpha, the other zero is called beta. The sum of the zeros is given by the coefficients minus b by a. The product of the zeros, alpha beta, is given by the coefficients c by a. In quadratic polynomial, formation of quadratic polynomial equation whose sum of zeros is equal to 6 and product of zeros is equal to 8 is given by the formula k. K stands for constant multiplied by x squared minus sum of zeros into x plus product of zeros. K is used to simplify the equation to remove the fractions in the coefficients above. Now in the quadratic equation 4x squared minus 20x plus 21, you have to factorize and find the relationship between the coefficients. So a is equal to 4, b is equal to minus 20, c is equal to 21. We must split the middle term minus 20x into two terms, the product of which is coefficient a multiplied by coefficient c. Here AC is equal to 84. The middle term can be split as minus 14x and minus 6x, the sum of which becomes minus 20x. Also, minus 14 into minus 6 gives you plus 84, which is equal to A multiplied by C coefficients. So 4x squared minus 14x minus 6x plus 21 is equal to 0. Have two factors, 2x minus 3 multiplied by 2x minus 7, which is equal to 0. Therefore, 2x minus 3 is also equal to 0. 2x minus 7 is also equal to 0. Therefore, the zeros of this polynomial are x is equal to 3 by 2 or x is equal to 7 by 2. Now, having found the zeros of the polynomial, two zeros, that is one is alpha and one is beta, the sum of two zeros alpha plus beta is 3 by 2 plus 7 by 2, which is equal to 10 by 2, which is in standard form 5. Product of zeros alpha beta is equal to 3 by 2 into 7 by 2 is equal to 21 by 4. Therefore, the quadratic polynomial equation is k multiplied by x squared minus sum of zeros multiplied by x plus product of zeros. Here k multiplied by x squared minus 5x plus 21 by 4. But we are having constant as a fraction. To convert this polynomial into standard form, to simplify the equation, we use k and multiply the entire equation by 4. Therefore, the quadratic polynomial becomes 4x squared minus 20x plus 21. How will you draw graph for polynomial equations? If you have linear polynomial 4x minus 2, equate it to y. That is 4x minus 2 is equal to y. Give the value of 0 to x. Here y becomes minus 2, x1, y2, and x if you give minus 1, y becomes minus 6, x plus 2, then y becomes 6, x 0.5, then y becomes 0. Now plot these points in the graph sheet. It will be a straight line. Now the straight line will cross the x-axis at the point of x, which is equal to plus 0.5. It will cross x-axis at the point plus 0.5. Quadratic polynomial graphical representation. Let us take, for example, x squared plus 7x plus 12 is a quadratic polynomial. Equate this to y. X squared plus 7x plus 12 is equal to y. Give some value for x and y. If x is minus 3, y is 0. X is minus 4, y is 0. X is minus 1, y is 6. X is minus 2, y is 2. Therefore, when the y coordinate are zeros, that is where the parabola crosses the x-axis. The parabola crosses the x-axis at x value point minus 3 and minus 4. Quadratic polynomial graphical representation. Parabola curves downwards if the coefficient of x squared is in the negative. Cubic polynomial graphical representation. It will cross the x-axis at 3 points. For example, x to the power of 3 minus 4x equated to x to the power of 3 minus 4x is equal to y. If you give the value of x is equal to 1, y is equal to minus 3, x is equal to 0, y is equal to 0, x if you give 2, y is equal to 0, x if you give minus 2, if you give 0, then x is equal to minus 1, y is equal to 3. Here in this table you will notice that y has 3 zeros for some value of x. The value of x where y is 0 is 0 to minus 2. This represents the x-axis where the curve will cross the x-axis at point 0, plus 2 and minus 2. In polynomial px 2x squared minus 3x plus 1, it is a quadratic polynomial. Find what is p1, p4 and p2. Here p1 becomes 0. If you substitute one value for x, then the equation becomes 0. Then x is equal to 1. If x is equal to 1, x minus 1 is its factor. For p2, the remainder becomes 3. If you substitute the value of 2 for x, the equation gives the value of 3. Because it is more than 0, therefore x is equal to 2, x minus 2 is not a factor because there is a remainder 3 for its value, it is not equal to 0. For p4, we get the value x is equal to 4 and this gives the remainder of 21. Therefore, x is equal to 4 means x minus 4 is equal to 0. Therefore, it is also not a factor of this polynomial 2x squared minus 3x plus 1. To find a factor of polynomial equation, the 0 of that polynomial equation by substitution of x value takes it to 0. That is factor theorem. If the polynomial equation by substitution of x value has a remainder, then that variable x is not the 0 of the polynomial. If x is equal to 3 gives a remainder which is not 0, then x minus 3 is not a factor. Now what are zeros of this quadratic polynomial 2x squared minus 3x plus 1, where coefficient a is equal to 2, b is equal to minus 3, c is equal to 1. It is in the form of ax squared plus bx plus c. It has got two zeros, alpha and beta. The sum of zeros alpha plus beta is given by the coefficient minus b by a, that is 3 by 2. Product of zeros is given by the coefficient c by a, which is equal to 1 by 2. The equation derived thus: k multiplied by x squared minus x into sum of zeros plus product of zeros. K multiplied by x squared minus x multiplied by 3 by 2 plus 1 by 2. So to standardize the equation, we give value 2, multiply the whole equation by 2. It becomes 2x squared minus 3x plus 1. That explains the significance of the term k. Now you have to know the difference between a quadratic polynomial and quadratic equation. The quadratic polynomial is a degree 2 equation, and the quadratic equation is also degree 2, but the quadratic equation is always equated to 0 to solve the problem. Whereas a quadratic polynomial p within bracket x or p within bracket y or p within bracket a, z, whatever be the variable involved in it, x, y or z, it has some value. It could be 0 or it could be more. If it is 0, then x factor becomes a 0 of the polynomial. That gives, if x is equal to 1, if it gets 0, then x minus 1 is a factor of that polynomial equation. Polynomials gave our algebraic identities: a plus b whole squared, a minus b whole squared, x plus a into x plus b, a plus b into a minus b, a plus b plus c whole squared, and so on, have all been born out of polynomials. The degree of polynomial where more variables are involved is found in the following manner as explained in the slide. 2x to the power of 3, y to the power of 6, z to the power of 4, a to the power of 7, b to the power of 6, first term, plus 5x to the power of 4, y to the power of 2, z to the power of 3, a to the power of 6, b to the power of 5, second term, plus 4x to the power of 3, y to the power of 8, a to the power of 7, b to the power of 7, third term, plus constant 4, fourth term. Here the first term exponents, x to the power of 3, y to the power of 6, z to the power of 4, a to the power of 7, b to the power of 6, gives us 26. 3 plus 6 plus 4 plus 7 plus 6, exponents of the variables, takes us to 26. In the second term, the sum of all variable exponents is equal to 20. In the third term, sum of all variable exponents is equal to 25. In the constant term, the exponent is always 0. So the degree of the polynomial is 26, determined by term 1. The problems you have in this chapter for board exams is limited to one variable. Let us now look at the graphical representation.